All right, class, good afternoon. Can everybody hear me okay?
Good afternoon. Hear you just fine.
All right. Well, let's check out this exam number 16 here. So we're solving using the square root method. So let's fix that. 1/10 x squared. We'll move the 23 over 5 to the other side. Now we'll multiply both sides by 10. Let's see here. And 2, hold on. However you want to do this, let's see. 230 divided by 5 is 46. So now we can square root both sides. That gives us the absolute value of x. So square root of 46. 46 is 2 times 23. 23 is prime, so we can't really simplify this any more than that. So we get plus minus the square root of 46. All right, for number 2, the same trick here. 1/3 x squared. We're subtracting 1/4 from both sides, right? So let's go ahead and simplify this fraction over here. 1/4 is 3/12. We multiply the top and the bottom by 3. So this gives us 1/12 over 12, which I guess we can simplify. Let's see, 1/12 is 2 times 56. So what, 2 times 23? 1/12 divided by 2 divided by 2 is 28. We can divide that by 2. We get 14, which is 2 times 7. 12 is 2 times 6, which is 2 times 3. So we got 28 over 3. So 1 long, then we have that equals that, right? So let's multiply both sides by 3. Not cubed here, squared. All right, so now we can square root. And we'll simplify this. 28 is 2 times 14, which is 2 times 7. So we can pull these out. So this is equal to this. We have absolute value of x is 2 root 7, or x equals plus or minus 2 root 7. All right, any questions? All right. So here's your quiz. It's on page 138. Got 2 problems there for you. It's 3:04, so let's take 15 minutes. Would put us at 3:19. So breakout rooms. All right, class, welcome back. All right, let's look at this quiz number 17, number 1. All right, our A here is 4, which is positive, so this thing opens upwards. Its axis of symmetry is at negative b over 2a, which is 0, because b is 0, so it goes right down the middle. So the vertex is at g of 0, which would be negative 5. So we have 0, negative 5. 1, 2, 3, 4, right here. All right, our y-intercept is the same as our vertex here. G of 0 is negative 5, so 0, negative 5 is our y-intercept. X-intercepts, we just set this bad boy equal to 0 and solve. So we have x squared equals 5/4. So x is positive negative square root of 5/2. Hey, calm down, puppy dog. All right, all right. Go outside there. Sorry about that, folks. All right, so 5, yeah, square root both sides. So I take 5, square root it, divide by 2. So this is plus or minus 1.1. So right here and right here. This guy looks like this. Which by looking at this, I could have told you. Remember x squared looks like that? This 4 here just stretched it vertically by a factor of 4. So instead of like this, it's more like that. And then the -5 just moved it down 5 notches. Domain, all real numbers because it goes forever right and left. The range, the lowest it goes is at -5 and it goes up to positive infinity. So for number 2 here, create a quadratic equation with solutions plus and minus √5. Well, what you do here is you just take x minus √5 and x plus √5. Technically, what I'm doing is this. I'm taking x minus and then each of the roots. So x minus a positive √5 and x minus a negative √5. Okay, which is the same thing. If we multiply this out, x squared plus √5x minus √5x minus 5, or x squared minus 5. Okay. Actually, I should write this a little differently. So let me put it like this. We want an equation, right? So there's our equation, which is the same as this equation, which is the same as this equation, which is the same as this equation. All right. So this is one quadratic equation with those solutions, right? I mean, if you just looking at this, you can tell the solutions would be plus or minus √5. There's other possibilities. What if I did this? Or, see, this would be 2x squared minus 10 equals 0, right? This is a different quadratic equation, but it has the exact same solutions as this one. I just multiplied everything through by 2. So this is your simplest answer. Any questions about this one? Okay. So we left off page 142. They want us to factor binomials completely. So the trick here is difference of 2 squares. You have an a squared minus b squared. This is a minus b times an a plus b. All right, you can tell because if you multiply those, you get a squared plus ab minus ab, then a minus b squared, and those cancel out. So we're going to use this a whole lot. All right, when there's no middle term, when you only have the a and the c, you can do that. This is the same thing as x squared minus 7 squared. So this is x minus 7 times an x plus 7. Boom, factored. You can check your work, of course, by multiplying this back out. But let me show you another example. Note, what if I had x squared minus 3? And I want to factor that. Well, 49 is 7 squared. Well, guess what? 3 is the square root of 3 squared. It doesn't have to be a perfect square. You can have any number there. You can rewrite any number as the square root of itself squared. So this would be x minus root 3 times an x plus root 3. Okay. So let's look at another example here, number 30. All right, this one, we could rewrite this. Yeah, as a 2x squared minus 9 squared. So 2x minus 9 times a 2x plus 9. Boom, factored. 31. This one's not the difference of two squares, right? Actually, it is. Remember, the square root of minus 1 is I. So I squared, the square root of minus 1 squared, which is minus 1. So we could take this plus 9 and rewrite it as a 3i squared. This I squared is a minus 1, and then the other minus makes a plus. So even if it's a plus there, you can still rewrite it as the difference of two squares. So this would be an x minus 3i times an x plus 3i. Okay. Test it out. X times x is x squared. We have plus 3xi minus 3xi. And now we have a minus 9i squared. Those cancel. This I squared is a minus 1. So the minus and a minus give us a plus. Okay. So if you have your variable squared, it doesn't matter what the numbers are, right? If I have a ax squared plus, I'll do a minus c, I could rewrite that as the square root of ax squared minus the square root of c squared. Factor, this would be root ax minus root c times root ax plus root square root of c. Or if this was a plus a number, I could say square root of ax squared minus the square root of c I squared, which would be root ax minus root ci root ax plus a root ci. So if you have something squared plus something, it doesn't, as long as your x is squared, you can always use the difference of two squares trick. All right, even if it's a plus, you can still rewrite.
You mute it yourself. Wait, can you hear me?
I can
Hello?
hear you.
Okay, I can't hear him.
Me either.
Okay,
How's that?
Okay.
okay,
I can hear you.
I'm back.
That. So how far do I need to go back here?
I think just like the end of that, like that problem.
This problem?
Yeah,
All right, but y'all heard me through these?
yeah.
That's weird. I wonder why my mic muted. Maybe when the dog started barking, huh? It automatically muted. All right.
No, I heard that.
All right, well, let's try this one again. All right, so we have a plus here instead of a minus. All right, but because I is the square root of -1, I squared would be -1. So we can rewrite this as a difference of two squares anyways, okay? We could rewrite this as x minus 3i squared. So the square root of 9 is 3. This I squared is a -1, and then the other minus give us that plus. So you could do x minus 3i times an x plus 3i. So there's the obvious ones like this. 49, the square root of 49 is 7, right? But then you have to consider things like this. 3, you can always rewrite it as the square root of 3 squared, right? So you can still rewrite it as a difference of two squares. So even if there's a plus here, you just throw an I in there, you still got a difference of two squares. So what I was saying here is it doesn't matter what it looks like, as long as your variable is squared and you don't have the variable here, you can always rewrite it as a difference of two squares. I can rewrite a as the square root of a squared and rewrite c as the square root of c squared, in which case you would get this stuff. If it's a plus, that just means you end up with an I in there to get that. I squared is a minus, and a minus gives you the plus. So if it looks like basically anything, as long as you don't have a b, ax squared plus bx plus c, if this isn't here, you can always rewrite this as the difference of two squares. And then it's easy to factor. So let's look at this one here. Here we can pull out a 2 and an x before we do anything. This would give us a 16x squared minus 1. So difference of two squares here. This is 4, let me do a square bracket. 4x squared minus 1 squared. So we have a 2x. This here becomes 4x minus 1 times a 4x plus 1. And it's factored. You can always multiply these out to check your work. Number 33. Okay, this one we can pull out a 25 here before we do anything. So we got x squared plus 4. Again, this is a plus, but we can still rewrite this as a difference of two squares by throwing that I in there. All right, the I squared is a minus, and the other minus gives us a plus. So difference of two squares, we got x minus 2i times an x plus 2i. This one they wrote it backwards. It doesn't matter. This is 7 squared minus x squared. 7 minus x times a 7 plus an x. Factored. If you want to turn it around, we can. If we pull a minus out of here, this becomes x minus 7, right? The negative x, and then the negative negative is a plus 7. And then this one we just flip. 7 plus x is the same as x plus 7. We can pull an x out of here. We get an x squared minus 1. 1 is the same as 1 squared. So we got an x minus 1 times an x plus a 1. And it's factored. We can pull a 3x out of here. So we give us an x squared minus 4. And 4 is 2 squared. So this would be an x minus 2 times an x plus a 2. All right, page 143. Okay, here's our graph of f of x. The x-intercepts occur at -5, 0, and 2, 0. You can use the x-intercepts to write the factored form of this quadratic function by moving the x-intercept to the other side. Basically, you do x minus each of your intercepts, -5 and 2, right? So this is x plus 5 and x minus 2. If we multiplied these out, we got an x squared, a minus 2x, a plus 5x, and a minus 10, or x squared plus 3x minus 10, which is exactly what the function says. So given the two coordinates, the two x-intercepts, we basically know what the function is. They do it a little differently, but it comes out to the same. They take they start off and they say x equals the x-intercept, and then they set the equation equal to 0. Okay. Let's see. So before we were starting with the function and getting the graph, basically here we're looking at the graph and trying to figure out what the function is. Okay, here x-intercepts at 0 and 4. All right, so we do x minus 0 and an x minus 4. We multiply this out. This is just x times x minus 4, or x squared minus 4x. It's exactly what they have up here, which I could tell that that's what it is. It's just by looking at it, but we're not going to worry about that right now. So let's look at another one here. 144. Sketch a possible graph. All right, we can tell by looking at this, if we set this equal to 0, all right, we could tell that x would be 5 or a -2. So right here, 1, 2, 3, those are our x-intercepts. A possible graph for that would be this, or this, or this, right? Given just that knowledge, any one of those would work, right? But to do it accurately, we need to look through all of our other properties here. Okay. That's why they say a possible graph. None of these are necessarily the graph of f of x here, but they might be. You know, those are all the ones that go through our two intercepts here. Same trick here. Looking at this, if x was either positive or -6, you would get 0, right? So we put a -6 in here, that would be 0. A +6 here would make that one 0. So 3, 4, 5, 6. So here's a possible graph. There's another one. Basically, any of them that go through there. We could tell because x times x would be an x squared, so it opens upward. Right, if we multiplied this out, this would be x squared minus 36. So the one that this would be the one where this is at -36, but looks just like x squared. Let's see another example. This one's a little different. So we can see the x-intercepts are at 3/2 and 4/3. A while ago, I said just do x minus 3/2 and then x plus 4/3, right? And that would be our function. But if you multiplied this out, we would get x squared minus 3/2 x plus 4/3 x minus 12/6. And if we simplify this, x squared, let's see, if we multiply 3/2 by a 3/3, It would be a 9/4. No, 9/6. And then this 4/3 multiplied by 2/2, we get 8/6. 12/6 is 2. So minus 1/6 x minus 2. So just doing x minus each intercept gave us this, but that's not the function, right? However, if I multiplied this whole thing by 6, then I would get 6x² minus x minus 12, which is exactly what that is. Basically, if I factored this guy, this is 6. It would be 6 times this, right? Because if I set this equal to 0, this has the same solutions as this. So the way they do it is they say, okay, set x equal to each intercept. And instead of just subtracting 3/2 from both sides, so you'd end up with x minus 3/2 equals 0, they multiply everything by 2 just to get rid of the fractions. All right. So the difference between this guy and just this guy is a factor of 6. All right. If we left the 6 out, it would go through the exact same spot, but it would be, instead of going down to -12, it would only go down to -2. Because this thing stretches it vertically by a factor of 6. So instead of going down to 2, it would be 6 times that. We go down to -12. All right. But what we need to get down here more than anything is simply being able to solve equations. So the 0 factor property means if you factor this thing, you can set each factor equal to 0. So if we factored this, this equation is equivalent to 3x. Just don't need that. 3x² minus 4². The difference of 2 squares. So this would be a 3x minus 4 times a 3x plus 4. So the 0 factor property says that this whole thing is 0 if either one of these factors is 0. Because if this is 0, it doesn't matter what that is. 0 times anything is still 0. So you just take each one of your factors, set them equal to 0. So this one says x is 4/3. This one says x is -4/3. So these would be our two solutions for this equation. So that's using the 0 factor property. Of course, we could have just done the root method, right? X² equals 16/9. Square rooting both sides, we get 4/3 plus or minus 4/3. Right, but they specifically asked us to do the 0 factor property. So we factor it, set each factor equal to 0. So this one over here, we need to put in standard form. If we subtract 9 from both sides, we would get that, right? 16 minus 9 is 7. Yeah. So to factor this one, we can eyeball it. We need an x and an x to give us the x², and a 7 and a 1 to give us the 7, but they add to give us the 8. So either x plus 7 is 0 or an x plus 1 is 0. This one says x is -7. This one says x is -1. Of course, you could have just written these down by looking at this. If I put a -7 there, I get 0. And I get 0 times a -6, which is 0. Right? With number 3 here. All right, we need to put this guy into standard form. So that is equal to that if and only if this is equal to 0. All right, to factor this, I can't really eyeball it because of that 2 there. So let's use our trick. Our A times C is 6. So we need 2 numbers that multiply to give us 6. Our B here is 7. Our 2 numbers need to add to be 7. So if we let P be 1 and Q be 6, those multiply to give us 6, and they add to be 7. So we'll take our 7x and rewrite them as 1x plus a 6x. Now we could factor this by pulling an x out. We get a 2x plus 1. Over here, we'll pull a 3 out, and we get a 2x plus 1 again. So we have an x and a 3, both times 2x plus 1. So either x plus 3 is 0 or 2x plus 1 is 0. So this tells us x is minus 3. This tells us x is a negative 1/2. And we have our solutions. We're going to do a lot of examples of these today. All right, this one, putting it into standard form. And you know what? I don't want to deal with all these fractions, so I'm going to multiply everything by 9. That's going to give me an x squared. 9 over 3 is 3 times 2 is 6. All right, so from there, I can eyeball factor that one. We need an x and an x for our x squared. A positive 9, but a negative 6. How about a negative 3? That gives us a positive 9 minus 3x minus 3x. Gives us that minus 6x. This is the same thing as x minus 3 squared. So x minus 3 has to be 0, or x is 3. Notice since this thing happens twice, this thing has its solution has multiplicity 2, because the solution occurs twice, the same number twice. All right, number 5. Let's put these in order least to greatest. And these coefficients, they don't have anything in common, so we can't really pull anything out of there. But we have a 4x cubed and a 20x squared and a 25x. We can pull an x out of everything. 4x squared plus 20x plus 25. So to factor this guy, let's do our trick here. A times C is 100. And our B here is 20. So 2 numbers that multiply to give us 100 but add to give us 20. I'm thinking 10 and 10. So let's rewrite 20x as 10x plus 10x. That way we can factor a 2x out of here and a 5 out of there. So I still have my x out here. I got a 2x plus a 5, and they're both times 2x plus a 5. So either x is 0 or 2x plus 5 is 0, which would be the same thing as x being a negative 5/2. And this one has multiplicity 2 because that factor shows up twice. All right, number 6. All right, looks like we can pull a 2 out of everything. T squared plus 9t plus 18. Then we could divide everything by 2. 0 divided by 2 is still 0. So if we're going to factor this guy, I think we can eyeball that one. We need a t and a t. 18, two numbers and multiply to give us 18 and add to be 9. How about 6 and 3? Yeah, there we go. So either t plus 6 is 0 or t plus 3 is 0. In other words, t is negative 6 or t is negative 3. The 7 here. Let's put it in the standard form. 10x squared minus 5x equals 0. I could pull a 5x out. That would give me a 2x minus 1. Right? So either 5x is 0 or 2x minus 1 is 0. This one's true only if x is 0. This one is true only if x is 1/2. So there's our solutions. This one has a whole bunch of fractions. Let's put it into standard form first. What can I do to get rid of these fractions? If I multiply through by 4 or 5 or 10, that'll only get rid of one of them. But the one number that's divisible by all three of these is 40. So if I multiply everything by 40, 40 over 5 would be 8. 40 over 4 would be 10. And then 40 divided by 10 would be 4 times 3 is 12. So this, if we do our A times C here, 8 times 12, we got a negative 72. B is 10. So two numbers that multiply to give us negative 72, but add to give us a positive 10. One of them is going to be positive, one of them is going to be negative. Let's see. Let's think of the possibilities. 2 and 36. Let's see, is 72 divisible by 3? It is. But their difference is not 10. What about 4? It's also 4 times 18. Their difference would give us 14. It's not divisible by 5. What about 6? 6 and 12. Their difference is not 10. 7, 8. 8 and 9. Their difference is only 1. 8, 9, 10, 11, 12. I already got 12 and 6. All right, what am I missing here? I need to add to give us 10. 8 times 12 is, that's why. 8 times 12 is not 72. It's 96. Which changes everything. So we need two numbers that multiply to give us 96. 2 and 48, but their difference has to be 10. So 3 and 32, no. 4 and 24 does not work. 96 divisible by 6, yeah, 6 and 16. That'll work if we let P be 16 and Q be a negative 6. They multiply to give us negative 96 and add to give us 10. So let's rewrite 10x as 16x minus 6x. So we can factor out of here a 4x, gives us a 2x plus 8. And over here, we could factor out a -6, which gives us, hold on. I need a 2x plus 8. Let me do something else here. Instead of pulling out a 2x, I can pull an 8x out of here. And that would give me an x plus 2. Then if I pull out a -6, I get x plus 2 again. So I got an 8x and a -6, both times an x plus 2. So either x plus 2 is 0 or 8x minus 6 is 0. This one says x is -2. This one says x is 6/8, which is the same thing as 3/4. So there's our two solutions. Number 9. Okay, this thing's in standard form. We can't factor any numbers out. So to factor it, let's do our trick. 25 times 8 is 200. B is 45. So two numbers that multiply to give us 200 but add to give us 45. 2 times 100 doesn't work. Let's see, 200, is it divisible by 3? No. It is divisible by 4. It'd be a 4 times 50, right? That doesn't work. Those add to give us 54. So if we divide it by 5, we got 5 times 40. Those work. They add to be 45. So let's let P be 5 and Q be 40. So we'll rewrite this guy, this 45x, as a 5x plus a 40x. So out of here, we'll factor a 5x. That gives us 5x plus 1. Out of here, we'll factor out an 8, and that gives us a 5x plus 1 again. So we got a 5x and an 8, both times 5x plus 1. So either 5x plus 8 is 0, or 5x plus 1 is 0. This one says x is -8/5. This one says x is -1/5. And those are our two solutions. Number 10. We can pull a 3 out of here, which will give us 3 times x squared minus 4. We can get rid of that 3, because this is still 0. X squared minus 4 is the difference of two squares. So this is x minus 2 times x plus 2. Looking at this, we could tell that either x is either a positive or a -2. Number 11. Let's get rid of the fractions. Multiply everything by 2. This is the difference of two squares. So we can factor it. X minus 8 times an x plus an 8. So obviously x is either a positive or a -8. This one, we could use the square root method, but they asked us to use the 0-point method, or 0-factor method. So this is 4t squared, and 49 is 7 squared. So 4t minus 7 times a 4t plus 7. So either 4t minus 7 is 0 or 4t plus 7 is 0. In other words, t is 7/4 or t is a -7/4. let's finish these two and then we'll take a break. Let's put this into standard form. 4x squared minus 11x plus 6 equals 0. Well, I can't eyeball this one, so a times c is a 24. B is a negative 11. So what can we do here? 8 and a 3, I think. If we do a negative 8 and a negative 3, they multiply to give us a positive 24, but add to be a negative 11. So let's rewrite this as minus 8x minus 3x. Out of here, we could factor 4x out. Out of here, we'll pull out a minus 3. So now we have a 4x and a minus 3, both times an x minus 2. So either 4x minus 3 is 0 or an x minus 2 is 0. So either x is 3/4 or x is 2. There's our solutions. One more before we break. Okay, we have 43 as prime, so we can't really do anything with this. We can do our trick. 15 times 30. 15 times 30 is 450. This is going to take a while. Our B here is 43. Okay. Let's look at our options. 2 times 225. That does not work. 450 divided by 3 is 150, but those don't work. 450 divided by 4 or 5. How about 5? 5 times 90. It's getting closer. 450 divided by 6. That's still not there. Divide by 7 or 8 or 9. This is 9 times 50. Those add to be 59, so we're getting closer. 10 times 45. No, it's not divisible by 11. Let's try 12. No. 13. 14. 15. 15 times 30. Those add to be 45, not 43. We divide by 16, 17, 18. 18 times 25. I think that's it. Those add to be 43. So let's let P be 18 and Q be 25. So we'll rewrite 43x to be 18x plus 25x. So out of here, we'll factor out a 3x, which gives us a 5x plus 6. And over here, we'll pull out a 5, which gives us a 5x plus 6 again. So we have a 3x and a 5, both times a 5x plus 6. So either 3x plus 5 is 0 or 5x plus 6 is 0. So either x is a negative 5/3 or x is a negative 6/5. And those are our two solutions. So that's the last of that page. When we come back, we will continue knocking these out one after another as fast as we can on page 146. It's 4:05. We'll come back at 4:20, folks. All right, class, y'all back with me?
We're here.
All right.
Well, I'm here.
Let's move on. We're on page 146, solving more equations. let's put this guy in standard form. I can't factor any numbers out of here, so we're gonna have to factor it as is. We get a negative 70 here. Our B is a -3, so let's see, numbers that multiply to give us 70, and their difference is gonna be 3. 2 and 35 does not work. 70 divided by 3, no. Divisible by 4, no. Divisible by 5, how about 5 and 14? No. 6, 7, and 10. Yeah, that'll work if the 10 is negative and the 7 is positive. So if we let P be -10 and Q be 7. So we'll rewrite this -3x as a -10x plus a 7x. So if I pull a 2x out of here, I get an x minus 5. If I pull a 7 out of here, I get a x minus 5. So I got a 2x and a 7, both times x minus 5. So either 2x plus 7 is 0 or an x minus 5 is 0. So either x is -7/2 or x is 5. And we have our two solutions. All right, number 16. I can't factor any numbers out, so let's do our trick here. What's 24 times 6? No, it's not 4. 24 times 6, 144 and negative. Our B here is 7. You got a 2 times 72. That doesn't work. See, since it's negative, we need one positive and one negative. Their difference has to be 7. So what about 3? 3 times 24? No. Let's see, hold on. That's not right. That isn't right at all. What the hell? Let's see, 144 divided by 3 is 48. No. Divide by 4. Get 36. No. How about 6 and 24? We're getting closer. 7, 8, 8 and 18. The difference is 10. We're real close now. 9 and 16. I think that's it. If we make the 16 positive, the 9 negative. So let's let P equal 16 and Q be -9. So let's rewrite 7t here as 16t minus 9t. So from here we could factor out what a 2t. That gives us a 3t plus 8. Over here we'll pull out a -3. It needs to be a plus. So we have 2t minus 3 times a 3t plus 8. So either 2t minus 3 is 0 or 3t plus 8 is 0. So either t is 3/2 or t is a -8/3. Those are our two solutions. Number 17. See, can we factor anything out all these? I don't think so. So let's do our trick. A times C. Oh boy. 75 times 12 is 900. B is negative 32. Actually, this is a negative 900. Okay, so 2 450, that doesn't work. 300, not a chance. 900 divided by 4, it's 225. Still not close. Or we have 5 times 180. 6 times 150. And we got 9 times 100. Or 10 times 90. Twelve times 75. 15 times 60, getting closer. 16 divided by 17, divided by 18. 18 times 50, I think that's it. If we make the 50 negative and the 18 positive, their difference is negative 32. So let's let P be negative 50 and Q be 18. So we'll rewrite this guy, this minus 32, as a minus 50x plus 18x. Let's see, what can we pull out of here? Pull a 2 out, right? 2x, that would give us a 6x minus 25. Over here, we can, let's see, I want to end up with a 6x minus 25. So what do I need to put here? A 3. That gives me 18x. And that, yeah, there we go. So we have 2x plus 3 times a 6x minus 25 equals 0. So either 2x plus 3 is 0 or 6x minus 25 is 0. So either x is negative 3/2 or x is 25/6. And there's our solutions. So 17, let's look at 18. I can pull an x out of everything and a 2. So let's do that first. So that would give me 15x squared minus x minus 2. So to factor this guy, our a times c here is a negative 30. Our b here is a negative 1. So I'm thinking P and Q can be negative 6 and 5. They multiply to give us negative 30 and add to give us negative 1. So we have a 2x. We're going to rewrite this minus x as a negative 6x plus a 5x. So we have a 2x. Out of here, I'm going to pull out a 3x. That'll give me a 5x minus 2. And this is 1 times 5x minus 2. So I still have my 2x here, but now I also have a 3x and a 1, both being multiplied by 5x minus 2. So this guy says either 2x is 0, 3x plus 1 is 0, or 5x minus 2 is 0. So this says x has to be 0. This one says x can be a negative 1/3. And this one says x can be a 2/5. And there's my 3 solutions to this third order equation. Number 19. All right, let's put it in the standard form. don't think I can divide anything out because 31 is prime. So A times C here would be an 84. B is a negative 31. So I need two negative numbers to multiply to give me positive 84, but add to be 31. So let's look at our possibilities. I could do 2 times 42. They're both negative. See, is it divisible by 3? Yeah, 3 times 28. I think that's the one. If they're both negative, they add to be negative 31. So let's let P be negative 3 and Q be a negative 28. So I will rewrite minus 31x as minus 28x minus 3x. So out of here, I'll pull out a 4x. I get an x minus 7. Out of here, I'll pull out a minus 3, and I get an x minus 7 again. So I have a 4x minus 3, both times an x minus 7. So either 4x minus 3 is 0, or an x minus 7 is 0. This says x is 3/4. This one says x is 7. And there's our two solutions for number 19. Number 20. See, I can divide everything by 10 for sure, right? That would give me an 8x cubed minus 6x squared minus 9x. But I could also pull an x out of that. Get an 8x squared minus 6x minus 9. So if I want to factor this, our a times c is a negative 72. Our b here is a negative 6. So two numbers that multiply to give us a negative 72, but add to give us a negative 6. I'm thinking negative 12 and a positive 6 satisfies that. So we can rewrite our negative 6x as a minus 12x plus 6x. So this guy, I could factor out a 4x, which gives me a 2x minus 3. Over here, I'll pull out a 3, which gives me a 2x minus 3 again. So I have an x, 4x plus 3, both times 2x minus 3. So either x is 0, 4x plus 3 is 0, or 2x minus 3 is 0. So this says x is a negative 3/4. This says x is a positive 3/2. And there's my three solutions for this third order polynomial equation. They really want us to hammer this home. All right, this one, let's do our trick here because we can't simplify. We have negative 30 as our a times c. B is a negative 1. So I'm thinking 6 and 5. Those add to give us a negative 1, multiply to give us a negative 30. So let's rewrite this negative t as a minus 6t plus a 5t. I'll factor a 3t out of here. That gives me a 5t minus 2. And I have a 5t minus 2. So I have 3t plus 1 both times the 5t minus 2. So either 3t plus 1 is 0 or 5t minus 2 is 0. So either t is negative 1/3 or t is 2/5. There's my two solutions for number 21. Let's look at number 22. All right, let's put this in standard form. All right, our a times c here, 12 times 6 is -72 again. Our b here is 1. So how about we do, let's see, what can we do? See, 2 and 36. 72 divisible by 3. Let's find out. 3 and 24 doesn't work. Divide it by 4. How about 4 and 18? No. 6 and 12? No. 8 and 9. There we go. If we do a +9 and a -8, we get our P and our Q here. So let's rewrite this plus x as 9x minus 8x. So here we'll pull out a 3x. That gives us a 4x plus 3. Here we'll pull out a -2, which gives us a 4x plus 3 again. So we have a 3x minus 2 times a 4x plus 3. So either 3x minus 2 is 0 or 4x plus 3 is 0. So either x is 2/3 or x is -3/4. And there's your solutions for 22. Look at 23. Okay, we can't simplify this. 23 is prime. So a times c, 7 times 6 is 42. B here is a -23. So let's look at our numbers, our possibilities. We got 2 times 21. 42 divided by 3 is 14. 42 divided by 4 doesn't work out. Of course, we have our 6 times 7. We're going to need two negative numbers to give us a positive, right? So 42, 7, 8, 9, 10, 11, 12, 14 and 3. Oh, we already got that. All right, I'm not finding anything. What am I missing here? 7 times 6 is 42. So yeah, the very first one, right? If they're both negative, they add to be -23. So -2 and -21. So we didn't need these. So I can rewrite this -23x as a -21x and -2x. So out of here, I'll pull out a 3x, not a 3x. We'll pull out a 7x. So it gives me an x minus 3. Here I'll pull out a -2, which gives us another x minus 3. So I have a 7x and a -2, both times an x minus 3. So either 7x minus 2 is 0 or an x minus 3 is 0. So either x is 2/7 or x is 3. There's number 23. Get 24. I can't factor any numbers out of here, so let's go with our trick. 6 times 4 is 24. B is 25. All right, clearly we can do 24 and 1 because they add to be 25. So we can rewrite 25x as 24x plus x. And I could factor a 6x out of here, which gives me an x plus 4. And then I have 1x plus 4 left. So I have a 6x plus a 1 times an x plus a 4. So either 6x plus 1 is 0 or x plus 4 is 0. So either x is a negative 1/6 or x is a negative 4. And there's my two solutions for 24. 25 has nasty fractions. You know what? We can just leave the fractions. This is 3/4 x squared minus 1/3 squared, which we can factor as a 3/4 x minus 1/3 times a 3/4 x plus 1/3. So either 3/4 x minus 1/3 is 0 or 3/4 x plus 1/3 is 0. This one says 3/4 x equals 1/3. If I multiply both sides by 4/3, I have x is 4/9. Down here, it's going to look exactly the same, but it's going to be negative. I think, yeah, negative 4/9. So there's my two solutions. Let me take a peek and see where I left off in my last class here. I don't want to go too far because I don't remember doing that problem. Nope. So it looks like I stopped at 22. Yeah, so we've already gone too far. I don't know how I managed to finish so much more quickly in this class. So let's do the exam. Here's your exam from page 149. Two problems. Just do what we just did like 50 times. Solve these using the zero factored property. And I'll see y'all on Monday.